All right, welcome to SEPAM. Today I'm Orisheje Matthew, and today we are going to be looking at the part 2 of the model answer to IGCSE Physics, paper 2, variant 1, October-November 2024. So in this part 2 video, we're going to be looking at question 21 to 40. So let's continue to the question paper. So we have question 21. An object is placed 20 cm in front of 18 converging lens. So this is a converging lens. The scale diagram shows the lens form real inverted image. So this is the real inverted image. Which row give the focal length of the lens and the distance of the image from the lens? So what we are interested in is the focal length. So let's magnify this diagram so that you can see very well. So if we magnify it, so you can have a better view. Now, the most important thing is that we are given the scale here. So from here to here, so this is 5 cm. So U is equal to 20 cm given in the question. So that's the distance from here to here, the object. But now, so from here, this is the focal, this is the focus. So because ray parallel to the principal axis after refraction through the lens is refracted through the focus. So the focus, if you look at the focus, so from the optical center C to F, that is the focal length. So what is the focal length? So you have this. And how many grids? How many grids? That will give you 8. 8 over 10 times 5. So that will give us 4 cm. So F equals to 4 cm. And then the image is from, the image distance is from here to here. So this is V, which is equal to what? 5 cm. We are given that 10 space here, the grid line will give you 5 cm. So you have V, F is 4 cm, and then the image distance. So distance of image and focal length. So the answer is A. Alright, so now radio wave are electromagnetic wave. What is the wavelength of a radio wave of frequency this? So the question here is all electromagnetic wave, all EMWs move at the speed of light, which is 3 times 10 raised to the power 8 meter per second. So that is the only key to this question. So what is the wavelength? Wavelength is equal to speed of light divided by frequency. So that will be 3 times 10 raised to the power 8 meter per second divided by 2 times 10 raised to the power 5 hertz. So if you carry out that division, that will give you 1,500 meter. So D. Okay, question number 23. A candle flame is placed in front of a loudspeaker. So this is loudspeaker. The loudspeaker produces sound wave that cause air particle to vibrate. The vibrating air particle make the candle frame vibrate in the same direction as the air particle. So what you know is that what? So sound wave is going to travel in this direction. So this is the direction of sound. Okay, and then the air particle will also vibrate in this direction. So this is particle. So particle vibration. And then so what longitudinal, and then so direction of vibration of particle is longitudinal, is parallel to the direction of the sound wave transmitted, and then it's also a longitudinal wave. That is 23C. Now 24, which part of the magnetic field around the strong magnet in where do you have the strongest force? So the closer the magnetic field, the greater the force. So that is point A. Now, there's a current of 0 point this in a closed circuit. How much charge passes a point in the circuit in 0.2 seconds? So the quantity of charge Q is equal to IT. So W is equal to, so we have that 0.60 ampere multiply 2.5. So you just say 2.5, convert it to second, multiply by 60 seconds. So that will become 90 coulomb. So the answer is C. Okay, question 26. Which physical quantity have the unit J divided by coulomb, JC? So you remember that electrical energy is equal to the voltage multiplied by the current multiplied by the time. So you can also put it is equal to VQ. So then make V sort of formula. V is equal to E over Q, so which is equal to Joule divided by coulomb. So that represents electromotive force and potential difference. C. Number 27. Okay, you have a copper wire is placed in an electrical circuit and its resistance is measured. The wire is then replaced with a second copper wire with twice the length and a quarter of the diameter. What is the ratio of the resistance of the two wire? All right, so the first one here we have you have the first copper wire. Okay, and then resistance is equal to resistivity multiplied by length divided by cross-sectional area. So a copper wire is placed in an electric circuit and its resistance is measured, that is R. The wire is then replaced with a second wire with twice the length. So we have what? L is equal to, the L2 is going to be what? 2L. That is the original copper wire. And then quarter of the diameter. So how is diameter related to area? We know that okay, since we have the diameter, quarter of the diameter, that means d over 4. So okay, d2 is equal to d over 4. Okay, so if d2 is equal to d over 4, and we know that so this one is going to be all right, so let's find the radius. So radius of this is going to be d over 8, while the radius of this is going to be d over, so this one is going to be real L. So in the place of the area will become pi multiplied by d square over 4. Okay. So in other words, so arrow 1 is going to be 4 real L over pi d square. So let's get arrow 2. What is going to be arrow 2? So you put this formula in this. So what is going to be arrow 2? Arrow 2 is going to be substitute L, so become 2 real L, because this is 2L, put it in place of the length. Then in place of the area, we're going to have, this is equal to the radius, that is arrow 2, is equal to divided by pi d square over 64. So this one will now be 64 times 2 is equal to 64 times 2. 64 times 2 so that is 128 real L over pi d square. Okay, so that's the resistance. What is the ratio of the resistance for the two wire? So wire 1, so this one here to this is going to be 4 to 128. So that will be 1. So you have 128 divided by 4. So that will give us 1 to 32. 1 to 32. So number 27 is D. Okay. Oh, sorry. Okay, so let's look at question 28. Which circuit contains a diode connected in series with a fixed resistor? A diode. So first of all, to be able to, this is what? Light dependent resistor, LDR. This is a resistor. This is a variable resistor. This is a thermistor. And then, so this, the answer, you have what? Fixed resistor and a diode connected. So fixed resistor and a diode connected, that is this. So fixed resistor, diode. So question 29. So we have in the circuit shown, S has twice the resistance of Y. So this one is what? So if here is 2 ohm, here is going to be 1 ohm. So, and then the current flowing through here, so if this is V, the PD across each of the resistors is the same. So V is equal to Vx and is equal to Vy. And then what is going to happen? I is equal to Ix plus Iy. So the current coming here is I. And then when it comes here, it's split into Ix and then it goes to what? I, Y. Now, the resistance is here, so the current that will come here, the current that's going to pass through Y will be twice that of X. So, I, Y is equal to 2I, X. So, which of the statements about the circuit is correct? So, the current in the cell is greater than the current in X. Okay? The current S is greater than the current Y. No, it's less than. The potential difference across the cell is greater than the PD across S. No, they are equal. The PD across S is greater than the PD across Y. No, they are equal. Sorry. Okay, question 30. A 4 ohm resistor and an 8 ohm resistor are connected in series with a power supply. A voltmeter connected across the 8 ohm reads 36 volts. Now, what is the reading across? So, let's have this simple diagram like this. So, you have two resistors. Then connect to the second resistor. So, this one is 8 ohm. And then this one is 4 ohm. Then the voltmeter reading across this, it reads 36 volts. Okay, so what will be the voltmeter reading across this? So remember that the current flowing through them is the same. So I is equal to the PD across this over 4 ohm is equal to 36 over 8 ohm. So if you balance this, so what is V? V is equal to 36 over 8 times 4. So that is equal to 18 volts. Number 30 is B. Okay, now a metal rod SY placed in a magnetic field so that it is perpendicular to the field shown. In which direction will the rod move so that there is an induced EMF from Y to X? So it's going to behave induced EMF. So it's behaving as a generator. So we are going to use right hand rule. So if you use your right hand rule, so if you have the magnetic field going, and then here, okay, we have the current going this way. So this is the current I, and then finally you now look for, so let's get this. So this will come like this. So this will be the motion, which is the thrust. Okay, so if you do this, okay, all right, okay, so this, all right, so this is it. You can see my hand. Okay, so the motion is coming towards the face of the observer. Okay, so out of the paper towards the observer. So the answer there is D. Okay, now let's have a question. Okay, question 32. The diagram shows the basic electric motor. So just the component here. So this is what is this part? This part is the coil. and then this is the brush, and then this is the commutator. Okay, so that is the commutator. So we have S is coil, S is coil, Y is brush, and then Z is the commutator. So coil, brush, commutator. So the answer is B. Now number 32. Two transformers. Okay, two transformers, that is P and two transformer P and Q, each having 200 ton on their primary coil and 100 ton on their secondary coil. Both transformers are 100% efficient. So now the second transformer is connected to the primary transformer Q. So we have, this is the diagram we have here. So we have this transformer, then connected to this transformer here. So this is P, and then you have transformer Q. So transformer Q is now connected again. And then this one goes like this. Okay, so now here is 200 ton and here is 1000 ton. So the ratio here is half. So it's a step down. And then this one 200 and then 100. So you have, what is the factor? We have so let's look at what is going to happen here. Q produce the current, which is what? 0.2 ampere. So, and when it now come here, so this current reduces to 0.1 ampere. And then when it comes here, it reduces to 0.05 ampere. So the answer here is D. Okay. Number 33. All right. So what we have here is you can scan this barcode and barcode so that you can connect with me on WhatsApp. So we can discuss further, and you can join the WhatsApp group where we discuss questions that can help to improve you. So you make suggestion. So that is all right. So question 34. Alpha particles are directed at a metal foil. Most of the alpha particles pass through the foil with little change of direction. So you have this, and then you have the nucleus at the middle, and then let's have those particles, bring them in. So they come here, pass through or deflected, undeflected, and then these ones okay, return back. Then this one, okay, slightly deflected, and then these ones that come here. All right, so we have this situation. So in this very particular situation, what does the evidence suggest about the structure of the atom? Okay, the answer is C. It consists of what? Charge center, okay, smaller than the size of the atom, the diagram, but with most of the mass of the atom. So that's why the deflection that takes place here. The nucleus is massive, but the size is very small. That's why most of this thing pass through. Okay, question number. So let's look at question number 35. Okay. Which statement correctly compare the property of alpha particle and beta particle? Okay. So the answer here, alpha particle are less penetrating than beta particle because alpha particle are more ionizing because of their size. Okay. So if you have the cloud, so if you have this and then you release this, so alpha particle move, okay, slightly ionizing, okay, why the beta can move, okay. Then if it is gamma, well, if I just pass through small, okay, so this is alpha, this is beta, then this one no streak at all, this gamma. So in terms of thickness, so this one have higher ionization but shorter distance, okay. This one ionizes but through a long distance, but the ionization is not as thick as that. Well, just do further study on that, okay. Radioactivity. Now 36. Which statement about alpha decay is correct? Which statement about alpha decay is correct? So with alpha decay, the two nucleus loses electron. So okay, number 36, the nucleus changes to a different element. Okay, so if we have A ZX, then you undergo alpha decay. So this one is going to release alpha particle, so which is alpha. So you have what? 4 2, then plus A will now become A minus 4X, okay, and then this one will be what? Z minus 2. So this is a new element. All right. Question 37. An explosion in a nuclear reactor spread isotope caesium 13755 caesium across a large area. After 90 years have passed, the quantity of caesium present is this, of the original level. What is the half-life of caesium 137? So we have this. So 100%, 0, so it goes to 50%, then it goes to 25%, then it goes to 12.5%. Then 100%. So this is at 0 time. Then so this point here is the first half-life. So then it comes to this place, you have the second half-life, then you come here, you have the word third half-life, and then the total half-life, so 3 half-lives to give you 90 years. Okay, so 1 half-life is equal to 90 divided by 3, so which is equal to 30 years. So the half-life is 30 years. Number 38. Which type of object rotates round the sun with an elliptical orbit? So you have the sun here, massive, then you have this ellipse. So here you have, so this is the planet. Okay, so revolve around the sun. So you do that. Okay, question: which statement about the sun is correct? Okay, question 39. The sun is powered by fusion reaction and electromagnetic radiation is produced. Okay, question 40. Wow, we're good. Making good progress. Now, measure the distance of a galaxy from the Earth as 2.5 times 10 raised by 21 kilometer. So that is the D. So we have D, 2.5 times 10 raised power 21 kilometer. And then the galaxy is receding from the Earth with the speed of V is equal to 5.2 times 10 raised power 3 kilometer per second. So we are expected to find the Hubble constant. Hubble constant A is equal to velocity of receding star all over the distance from Earth. So which is equal to 5.2 times 10 raised to the power 3 kilometer per second divided by 2.5 times 10 raised to the power 21 kilometer. So this is going to give us 2.08 times 10 raised to the power -18 per second. So the answer is B. Wow, with this we've come to the end of this. All right, so subscribe to Super Easy Physics and Mathematics, and then with this you can connect with me on WhatsApp. I wish you good luck as you prepare for your exam. Watch out for other tutorial that will be uploaded in this channel, so I'll advise you to subscribe.